Chapter 6, Exponential Functions and Sequences. 6.1 is Properties of Exponents. So let's talk about zero exponents first. Anything except for 0 itself raised to the power of 0 is going to equal 1. 0 to the 0th is undefined. But that means anything raised to the 0th equals 1. So 14th to the 0th equals 1. The quantity 2x raised to the 0th equals 1. All of these are going to equal 1. It doesn't matter what you're raising to the 0th, it's going to equal 1. Okay. All right, so now let's look at negative exponents. If you have x raised to the negative y, you can write that with a positive exponent, but by putting it in the denominator of a fraction with 1 in the numerator. So it'd be 1 over x to the positive y. Okay. All right, so it's assumed that when we're simplifying that we don't write negative exponents in our final answers. So y to the negative fifth, I can rewrite that as 1 over y to the positive fifth, and then it's considered simplified. Okay. All right, so let's look down at part B down here. So 3 to the negative second, I can think of that as 1 over 3 to the second. I can still simplify a little bit farther. 3 to the second, that's 3 times 3, so that's going to be 9. So 1/9, that's completely simplified. Okay. When you have multiple pieces, what I like to do on these, you could take each part of this and think of that y to the negative fourth as 1 over y to the fourth, and this is 1 over x to the seventh. But it'll get really messy like that because we'll have a lot of layers in our fraction. What I like to do on a problem like this is any part that has a negative exponent, I'm going to move it upstairs. So I'm going to move this y to the negative fourth upstairs, and then it'll have a positive exponent when it moves. Okay. And the same thing, I'm going to move this down, and I'm going to move this down. So I'm using the stairs for all the pieces that have a negative exponent. So the y to the fourth will end up in the numerator. The 2 to the third, well, now with a positive exponent, will be down here. And x now to the positive seventh will also be in the denominator. Okay? And then the only other simplifying I can do is 2 to the third is going to equal 8. So this is going to be y to the fourth over 8x to the seventh. Okay. All right, I'm going to do the same kind of thing here. So I'm using the stairs for these two pieces because they both have negative exponents. Now you have to be really careful. A lot of times people will move 2x, the whole 2x, down to the denominator, but you don't want to do that because the negative fourth is only the exponent for the x part. It's really 2 to the first times x to the negative fourth. Okay. It would be different if I had parentheses around 2x and the whole thing is raised to the negative fourth, but only the x part is raised to the negative fourth. Okay, so that means I'm going to leave the 2 where it is. Okay, so let's think about the 2 is going to stay up top. Now the z is going to move up, so it'll be z to the fifth. I think it's a good idea to use a little line through your z's so it doesn't get confused with the 2. All right, and then x to the fourth will be down here once the x's move down, and y to the third. Okay. So now let's look at the product property, the product of powers property, I should say. So when we have two expressions like this that we're multiplying together, or two terms we're multiplying together, I've got x raised to a and x raised to b, and I'm multiplying them together. Notice they have the same base. Okay, the base of both of these is x. Well, when that's the case, you can add together the exponents. So that's going to become x to the a plus b. All right, so if we apply that right here, I'm going to have x to the 3 plus 5. So this will be x to the 8th. And if you think about it, it makes sense. I got 3 x's here and then 5 more x's. It's all multiplied together, so that means there's going to be 8 total x's all multiplied together. Okay? And you could simplify 3 to the third, then simplify 3 to the seventh, then multiply it all together. That would work. But you can also take a little shortcut. This is going to be 3 to the 10th. And then I'd still want a calculator for that. So let's see, 3 to the 10th is going to equal 5,949. Okay. All right. Next up, so here this is interesting because we do have these bases that are the same, but we also have the 2 and the 3. So here's how we can think about this. I can multiply the 2 and the 3 together because I can rearrange these. I just have 4 things that are multiplied together, so I can rearrange the order of them, right? I could write it like this. I'm just using the commutative property of multiplication there just to move the pieces around. And then, hey, 2 times 3 is 6. And then I've got 4 x's and 5 more x's, so 4 plus 5, there'll be 9 total x's using that product of powers property. Okay. Same kind of deal here. You could start simple. You could mess with the x to the negative 6 and write it over as 1 over x to the 6, but I'm going to wait for that and see what happens when I do the multiplication. So let's just rearrange these pieces first. Okay, 5 times 3 is 15. And then we can add our exponents together. So I've got 8 plus negative 6. That's the same as 8 minus 6. So now I've got 15x to the second. And I don't have a negative exponent anymore, so then I don't have to deal with that once I've done the multiplication there. Okay. All right. So that's what happened when we multiply two things with the same base. Let's look at what happens when we divide with the same base. What's going to happen if you have the same, you can think of this as division, right? The top divided by the bottom. And since the base is the same, you can write it as x to the a minus b. So when we were multiplying with the same base, we added the exponents. When we're dividing with the same base, we're going to subtract the exponents. Okay, so let's try it out here. So this is going to be x to the 7 minus 2. So it's going to wind up at x to the 5. But let's talk about why that's true. If I actually expanded this, 1, 2, 3, 4, 5, 6, 7. 7x is all multiplied up there, and 2 down here. And then if you started canceling, I can cancel out these 2 x's down here with 2 of the x's in the numerator. And if you count up what's left, you'd have 5 x's. So this is x to the 5th. Okay? Of course, if you had big numbers, you wouldn't want to do that. If I had x to the 100th and x to the 27th, I wouldn't want to write out all those x's. So much quicker to just think, oh, this is going to be x to the 7 minus 2, which is x to the 5th. Okay? All right. So this one, this next one, a lot of times I'll see people put x to the 7th for this one because they took the 10 and subtracted the 3. But you always take the top exponent and subtract the bottom one. So that means I'm going to get x to the negative 7th here. Okay? And then I want to write that with a positive exponent, so I'm going to get 1 over x to the 7th. And it kind of makes sense. If you expanded these again, we'd have 3 x's on top and 10 on bottom, and you'd cancel out the 3 on top with 3 of the ones on bottom, so you'd still have 7 x's left in the denominator. Right? You wouldn't have any in the numerator, but you'd still need a 1 up there just to show that the 7 x's are in the denominator. Okay? All right. On problems like this where we have coefficients, I like to kind of think of these parts separately. So first I think, well, 4 divided by 2 is 2. 4 halves is 2, right? And then I've got, for the x's, I'm going to do x to the 6 minus 2. And so then this will be 2x to the 4th. Okay? Just separate this out a little. Okay. So let's use that same principle here. I'm going to think of that as its own fraction, and then I'm going to multiply it by whatever that second fraction equals. So 3 over 15 is going to reduce to 1/5, because you can divide the top and bottom by 3. And then for the x's, I can think of that as x to the 5 minus 9. So now I've got 1/5 times x to the 4th. X to the negative 4th, excuse me. Okay? And I want to write x to the negative 4th with a positive exponent, so I'm going to think of that as 1 over x to the 4th. And then so when you multiply this together, we'll multiply straight across 1 over 5x to the 4th. Okay. On the next page, I just found a little typo because I was doing some copying and pasting. So this next thing is going to be called the power of a power property. It's supposed to say of a power property. I'll fix that on the note-taking guide. But this is when we've got an exponent and it's raised to another exponent. And what we're going to do when it happens is multiply the exponents together. So this is going to be x to the a times b. Okay? So if we use that principle here, I've got x to the 3 times 8, which would be x to the 24th. Okay? And if you actually expanded it, inside these parentheses, that's x times x times x, and you'd have that 8 times. So you'd have 8 groups of 3x's, so that's why it's going to be 3 times 8. Okay? And yeah, you could write this as 9 to the 4th. That would work. But you can also say, hey, this is 3 to the 2 times 4, which would be 3 to the 8th. And then I'm going to use a calculator there just to make this quick. 3 to the 8th is 6,561. Okay. All right, next up, we've got the power of a product property. So we got a and b are multiplied together, and then it's raised to the x. And this is going to be ab, the quantity ab to the x power. What's going to end up happening is we're going to have a to the x times b to the x. Okay, so you can kind of think about distributing that exponent if you want to, like that. The thing is, you want to be careful. There's only one term in the parentheses that's getting raised to the x, and people get confused when there's multiple terms and they start distributing the x, and it doesn't work like that. But it does work like that when we only have one term. Okay, so looking at this, if you think about what this means, it's 3x times 3x times 3x. Well, there would be 3 3's multiplied together and 3 x's, right? If you had 3x times 3x times 3x. So yeah, we got 3 3's and 3 x's. And then we can simplify that. Remember, 3 to the third is not 9. I see that all the time. 3 times 3 times 3, it's actually going to be 27. So I get 27x to the third. So we raised the 3 to the third and the x to the third. Okay? And we can do the same kind of thing here. So I'm going to take 2 to the negative fourth and y to the negative fourth. Now, you could also just put 1 over the quantity 2y to the 4th power. That would work, okay? But I was just trying to illustrate the power of a product property here. So then I would think of this as 1 over 2 to the 4th and 1 over y to the 4th to write it with positive exponents, okay? And then when we multiply straight across, we're going to get 1 over 2 to the 4th, y to the 4th. And 2 to the 4th, let's think about that. 2 to the 2nd is going to be 4. So we're going to have 4 times 4. That's 2 times 2 times 2 times 2 is 4 times 4. So that's going to be 16 y to the 4th when you multiply that out. Okay? That was the power of a product property. Product is when we're multiplying. So now we got the power of a quotient property. So we're dividing these two things and then raising it to a power. And it's going to work in a similar way. It's going to be a to the x over b to the x. Okay? So let's try it here. We've got, here we're going to have, so again, you're kind of distributing. We've got x to the third times negative 3 to the third. Okay, and I'm putting that negative 3 in parentheses because I want to make sure that we're taking negative 3 times negative 3 times negative 3. Not 3 to the third and then the opposite of that. Although it turns out it's the same there, but kind of a good habit. So negative 3 times negative 3 would be positive 9 multiplied by 1 more negative 3. That's negative 27. Okay. All right. And let's try this one here. Oh, so there's a nice little, you can actually just flip the fraction upside down and then this exponent on the outside will be positive. So that's a nice little shortcut. But let's just do this using the method I was just showing. Okay, so I'm going to get 2x, the quantity 2x to the negative third, because I want to show that the whole thing is getting raised to the negative third, not just the x. Okay, and then I've got y to the second raised to the negative third. All right, So now up on the top, we can think of this as 2 to the negative third times x to the negative third. And on bottom, we can multiply the exponents together when we've got an exponent raised to another exponent. So this would be y to the negative sixth. Okay? So now that I've got this fraction with these multiple pieces and I've got some negative exponents, every part that has a negative exponent, I'm going to use the stairs. So that'll become positive. Okay? So that's going to leave me with the y is going to move up to the top, and that's y to the positive 6. 2 to the 2 will come down there. Now 2 to the third, and the x to the third will come down. Now the only thing left to do, 2 to the third, 2 to the third is 8. 2 times 2 times 2. So 8y to the 6 over 8x to the third. Okay. All right, that's the end of the section, and I'll see you next time.